In the vast stretches of the cosmos, there exists a world far from the familiar warmth of the sun. A world that seems to defy every rule we thought we understood about planetary motion. Welcome to Uranus, the seventh planet from the sun, a frozen giant shrouded in mystery, with a tilt so extreme that it turns everything we know about planetary behavior upside down. Uranus is a celestial enigma, a world that behaves in ways few can imagine, where time itself feels altered by its eccentric axis. Imagine a planet spinning not like the others, but almost on its side. Imagine a world where the cycle of day and night lasts for decades, where one pole experiences unyielding daylight for 40 years, only for it to be plunged into 40 years of unbroken darkness. Uranus spins sideways, an oddity that sets it apart from every other planet in the solar system. But how did it get here? What caused Uranus to rotate like this, leaving us to ponder the true nature of our cosmic neighborhood? This strange tilt is not just a quirk of nature, it is a clue that reveals the violent history of our solar system. To understand Uranus, we must unravel a story of cosmic collisions, gravitational dramas, and the forces that shaped the planets in the infancy of the solar system. Uranus is not the only planet to have an unusual tilt. Venus spins nearly upside down, while Earth and Mars are tilted just enough to give us seasons. But what happened to Uranus is a tale of cosmic violence. Imagine the solar system as a battlefield, where planets and planetoids fought for position in a young, unstable neighborhood. Uranus, one of the ice giants, was no exception to this chaos. Uranus' axial tilt is believed to be the result of a cataclysmic collision early in the solar system's history. Scientists speculate that an object the size of Earth, possibly a rogue planet or a large planetary embryo, struck Uranus with such force that it knocked the planet completely off its upright axis, spinning it sideways into its present position. This violent impact may have completely disrupted its formation, setting in motion the unusual rotation that defines Uranus to this very day. This impact, which likely occurred billions of years ago, could also explain why Uranus moons are so peculiar. Many of them orbit in strange, tilted planes, as if still adjusting to the violent aftermath of the collision that altered their parent planet's spin. The moons of Uranus, with their irregular orbits, are the scars of a planet that was forever changed by this cosmic assault. Now, let's take a closer look at what this tilt means for Uranus today. While Earth has a tilt of about 23.5 degrees, which gives us our changing seasons, Uranus' tilt is so extreme that it is nearly 90 degrees, causing it to roll sideways around the Sun. The result is an orbital pattern like no other. As Uranus orbits the Sun over the course of 84 Earth years, its poles alternate between long periods of continuous sunlight and long stretches of absolute darkness. For 42 years, one pole is exposed to the sun in a perpetual summer, while the opposite pole lies in darkness. This cycle flips as the planet continues its orbit, causing extreme and prolonged seasonal shifts. The poles of Uranus experience an entire season that can last decades, unlike the relatively short cycles we experience on Earth. Meanwhile, the planet's equator remains in a state of near-constant twilight, transitioning between day and night with relatively little variation. This axial tilt causes a dynamic and unpredictable climate, creating fascinating weather systems on the planet. Uranus is an ice giant, composed mostly of hydrogen, helium, and methane gas. The tilt of the planet causes extreme temperature fluctuations, with one hemisphere receiving sunlight for decades, while the other remains frozen in shadow. This creates temperature gradients across the atmosphere, with drastic differences in temperature between the poles and the equator. These temperature contrasts could be responsible for the violent wind systems that characterize Uranus' atmosphere. Winds on Uranus are thought to reach speeds of over 900 miles per hour, much faster than those on Earth. These fierce winds, coupled with the planet's extreme tilt, likely generate powerful storms and strange cloud formations, though much of it remains hidden beneath a thick, featureless layer of clouds. The clouds of Uranus are primarily composed of methane, which gives the planet its characteristic blue-green color. These clouds, however, are not like the clouds on Earth. They may be composed of unknown ice crystals and volatile compounds that we don't yet fully understand. This makes Uranus a fascinating subject of study in the search for new atmospheric phenomena. Uranus moons are just as strange as the planet itself. Unlike the moons of Jupiter or Saturn, which have relatively stable orbits, the moons of Uranus appear to have been affected by the planet's tilted axis. Some moons, like Miranda, exhibit dramatic geological features, with cliffs that rise hundreds of kilometers high and valleys deeper than the Grand Canyon. It is as if these moons have been torn apart and reassembled over time, the scars of a planet that once endured immense gravitational forces. Miranda's surface is a patchwork of cliffs, ridges, and fractured regions, likely the result of tidal forces caused by Uranus' tilted spin. These forces could have stretched and compressed the moon over time, causing it to fracture and reconfigure. It's a vivid example of how Uranus' gravitational influence, combined with its tilt, has shaped the moons in its orbit. Titania, the largest moon of Uranus, is a world of ice and rock, while Oberon, with its craters and ancient surface, tells a tale of a moon battered by time. The orbits of Uranus moons are influenced by the planet's extreme tilt, which affects the gravitational dynamics between the planet and its satellites. It's a fascinating cosmic dance where the tilting axis of the parent planet plays a crucial role in shaping the orbits and physical characteristics of its moons. Though much has been learned about Uranus from the distant Voyager 2 flyby in 1986, this remains a planet that beckons further exploration. With the advancements in space technology, a new era of space missions could soon bring us closer to the icy giant than ever before. Imagine a spacecraft dedicated solely to Uranus, equipped with sophisticated instruments that could probe the planet's atmosphere, map its surface in unprecedented detail, and study the strange dynamics of its moons. What new discoveries will we make? Could Uranus hold the key to understanding the early stages of planetary formation? And might it even offer clues about the nature of exoplanets in distant star systems? Perhaps Uranus is not just an isolated world in the outer reaches of our solar system. Perhaps it is a window into a deeper understanding of how planetary systems evolve, how they are shaped by cosmic forces, and how worlds are born, destroyed, and transformed. Uranus remains one of the great mysteries of our solar system, its tilted axis a testament to the chaos of the universe, its moons a record of a violent past, and its weather systems a strange, dynamic force we are just beginning to understand. As we continue our journey through the cosmos, Uranus will remain a constant source of wonder, a reminder of the forces that have shaped, and will continue to shape, the very nature of the worlds around us.